Okay, now moving on to the next presentation, we have one of the early adopters of the TOPCon technology, basically a company which exclusively focused on N-type right from the beginning, which is Jolywood. We have Keng Siew Chan, who is a senior R&D director at Jolywood. He's going to talk about N-type technology development and mass production. Keng, the floor is yours.
Thank you. Can you hear me?
Yeah.
Okay, sure. Okay. Good morning, good afternoon, and good evening for audiences all around the world. My name is Keng. I'm from Jolywood. So today, I just want to give some updates on our N-type technology development and mass production, particularly from the point of view of us in Jolywood. So this is the content of my talk today. I'm just going to go through our profiles, some of the history of TOPCon development, Jolywood, PVD TOPCon technology, our path for efficiency improvements, our Jolywood, our technology roadmap in the future. So as the chair has mentioned, we are one of the early adopters of N-type technology, where we actually already started our N-type N-put mass production back in 2016, and also N-type TOPCon mass production in 2018. So we are founded in 2008, and then we are listed in Shenzhen Stock Exchange. We basically have 4 business units. So we have materials, we have cells, which we actually have a planned 16 gigawatts of TOPCon cell productions. We have modules, business unit, and PV systems, where we deal with customers from the downstream. And we're also one of the largest backsheet manufacturer in the world, with about 30% market share. And earlier this year, we become a subsidiary of Zhejiang Provincial Energy Group Company, or Zhejiang Power, a state-owned company in China. So I'm just going to go through the history of TOPCon. As some of you guys, I guess a lot of you guys are already an expert in this in this technology. So, but I'm just going to go through it briefly. TOPCon is the acronym for tungsten oxide passivator contacts. So it's basically using thin tungsten oxide together with a polysilicon layer stacks for both tunneling and conducting. So the concept is has been used in microelectronics, but in solar industry only until 2013, where Fraunhofer ISC demonstrated these TOPCon concepts with efficiency of more than 23% in small area silicon solar cells. So after that, the technology get developed further, and until now, where it's become one of the major mainstream technology for mass production in our industry. So in terms of theory, I guess this has been shown quite a lot of times. But in terms of theory, due to the high quality of the silicon oxide polysilicon layer stacks, for TOPCon passivated on both the surfaces, in theory, the efficiency can go reach 28.7 compared to HIT or HJT, which are passivated using amorphous silicon. They can, in theory, can go to 27.5 compared to PERC 24.5, which are passivated by with aluminum BSF at the rare surface and the phosphorus diffuse spiral surface. In terms of cost, due to the fact that TOPCon uses silver in both the front and rear surface, so the cost of production is slightly higher than PERC. I guess previous speaker already shown. So PERC, which uses aluminum paste on the rear surface. But compared to HJT, it's well known that it's slightly also a bit more costly to produce than TOPCon due to the fact that they use ITO. The indium is a scarce element, and also the need for specialized silver paste in HJT. So it's a bit more expensive than TOPCon. Due to these advantages of TOPCon, it has become one of the fastest expanded technology for mass production in our industry. So basically, from InfoLink data, there will be an additional 500 gigawatts of TOPCon cells productions this year alone, which will total production output target 1 terawatts. For TOPCon, basically for different manufacturers, the front surface are quite similar, but the major difference are at the rest surface on how the titanium oxide and the polysilicon layers are being made. We have three major mainstream TOPCon polysilicon deposition techniques, which are LPCVD, PVD, and PECVD. So I'll go back to this slide. So for LPCVD, it's been used by major manufacturers such as Jinko and Trina. And for PECVD, I guess the previous speaker already shown that they use PECVD is used by Tongwei. And for us in Jolywood, actually we started with LPCVD, but we use implantation to do the phosphorus diffusion. But now all our more than 10 gigawatts of cell production are using PVD. Each deposition technology has their own pros and cons, which I'm not going to go into details too much today. But basically for LPCVD, the industry standards are using they need in-situ doping. So you need additional phosphorus diffusions equipment after the polysilicon layer deposition. So compared to PVD and PECVD, where in-situ doping can be done, so there'll be additional equipment needed for LPCVD. If you use LPCVD for your TOPCon technology. So and also for LPCVD and PECVD, they are wraparound. So you need to remove the wraparound after your diffusions. While PVD, due to the technology itself, is also the way the system is being designed, there's no wraparound. I'm going to go to talk about our PVD technology. So as I mentioned, actually when we started in 2018, we actually used LPCVD to deposit our polysilicon layers. During that time, we used implantation to do the diffusions. So what we found is there are a lot of steps needed in order to make the TOPCon at the rare site. So apart from that, there are also wraparound, which if not being removed properly, it will create some new issues such as shunt path and leakage current, and also less aesthetic front surface. So we quickly moved to the using PVD to deposit our polysilicon layers. What we found is compared to our first gen, the steps needed are much lower in number, and we also can do in-situ doping. Another advantage is there's no wraparound, and so there are no yield issue consider wraparound removal, and also more aesthetic modules due to the fact that there's no wraparound on the front surface. So this is just our improvement when we choose move from LPCVD to PVD to deposit our polysilicon layers, and we minimize the leakage current wraparound, and also dark AL images caused by the shunt due to incomplete wraparound removal. And the wraparound, without wraparound on the front surface, the cell also look better in the modules compared to when the wraparound are not being removed properly. Similar to a lot of manufacturers, right, we also carry out loss analysis on our PVD deposited PVD TOPCon cells. And what we found is the major losses coming from the front surface. So it's in accordance to the TOPCon concept where the right surface should be passivated, right? So the front surface and will be our main focus for improvement. These include the improving the emitter surface passivations, the metal contacts recombinations, and also we also found some room for improvement for our rare site passivation on the N+ poly layers, and also of course we are also optimizing our grid to improve the shadings and also improving our ARC as well. Another technology that we have included in our production is actually currently a selective emitter. SE is actually already kind of a standard for most of the TOPCon productions. So so I'm not going to go too much into details, but basically it involves a new equipment investment, more BOM costs, and also have some new issue as well. But from our productions, we observe an efficiency improvement of 0.25 after the inclusion of or introduction of the SE process. Another technology that I'm going to talk about today is we recently announced a new technology for metallization, codenamed JSIM. So we developed in-house, and the technology allows us to use a new paste system and also a new firing optimization process, which help us to produce electrical contacts with low surface recombinations and resistivity, basically to high energy density implantations. And the new paste system also improved the humidity and heat resistance, which are useful for bifacial single glass modules. From our in-house tests, we observed efficiency gain of, after the JSIM metallization technology, we observed reach more than 0.3% now after the JSIM process on our cells. And then we also observed the improvement in the module reliability, particularly the ability to resist heat and humidity. And applying our JSIM technology together with our transparent backsheet single glass modules, we also passed the DH 2000. Performances, our transparent backsheet modules also produce about 1.29% more power compared to dual glass, basically coming from the lower operating temperature of the backsheet modules.
Keng, I think we lost you. You are on mute. Can you unmute yourself?
Okay.
Yeah.
Okay, you hear me now? So
Yes.
reset again. Sorry about that. Can you see my screen?
Yes,
okay.
Now I can see you and screen.
Okay, cool. Yeah, so I'm going to talk about our technology roadmap, particularly in the cell technology in the future. So as I mentioned, we are one of the earliest adopters and mass producers of N-type technology, where we already started with N-PERT mass production back in 2016. We actually started our TOPCon LPCVD deposited polylayers in 2018, and then we moved to our current PVD technology since 2020. And in the future, of course, we already have laid out the roadmap to achieve more than 20. So currently, in our production line, we already can reach 26%. And in the future, we have the roadmap to achieve, for next year, achieve more than 6.5% efficiency, average efficiency in mass productions. And other technology that are developing similar to other large manufacturers is we are looking into back contacts as well. For quite some time now, and together with our TOPCon technology, we are looking into so-called TBC, right? And then we are aiming to get next year when it's ready for mass production to have an efficiency more than 27%. So this 27% is quite close to the theoretical limits of silicon solar cells, which is at about 29.43. So of course, we are also looking into other technology like perovskite, which together, if tandem with our current technology, we hope to achieve more than 30% in the future. Yeah, that's all my presentation today. So thank you very much.
Thanks, Ken. That's a very nice presentation. So you were the only one who is currently focusing on PVD technology, right? So are you planning to continue this PVD route?
Yes. So we have 16 gigawatts of productions. We actually have 8 gigawatts, more than 10 gigawatts of TOPCon cells already in production. All of them are using PVD. So for in the future, we are aiming to have 20 gigawatts. So all our cells are going to be PVD based.
So, but if you see the industry, you are probably the only one, if I don't know anyone. When it comes to the economy of scale, so industry is more or less split into either PCVD or LPCVD. So you are somewhat losing from the economy of scale from the production equipment, right? So do you feel you have already factored that in? Because production equipment, so many people jumping on one technology reduces the capex, right? But you are not worried about capex, or how this is working in favor of you?
Yeah, so our PVD technology has less fabrication steps. So basically, our costs are quite comparable to other manufacturers. Do I answer your questions? Yeah.
Yeah. Great. And and then regarding your back contact technology, so I just want to reconfirm. So next year you are planning to come out with a back contact based technology next year into commercial production, right?
Yeah, we need to go through pilot production, and we are still in R&D phase. And then we need to go through pilot production first, and after that we go into mass production. So it's just a plan, but hopefully we hope to actually start our pilot production next year.
Okay. Thank you very much. And if there are any questions, please stay back and answer. I think there is already a question, one or two questions I see in the chat window.